Okay, here I go. Actually, initially I forgot to press the record button. Now I did. Okay, so everybody see, today actually you will be making some practice. There are three problems that please everybody take your pen and paper. And this is one problem, and then there is other problem here, and then there is a third problem. So I have written down the answers for you. So everybody please make a practice. Uh, the first problem, everybody see, this is the circuit. So given the circuit in figure 1, R1 value is 2 ohm, R2 is 5 ohm, C1 is 0.1 farad, and C2 is 0.2 farad. So based on these given parameters, determine the transfer function Hs, V naught is over VIS. So this means you have to find out the voltage across capacitor C2, and then you have to establish this relationship. You have to find out Hs, V naught over Vi. So this should be the answer. Now, yeah, you all try, and then whether you are getting this result or not. So this is one problem. And then this is from that filter chapter or resonance chapter. In an electronic device, a series circuit is employed that has a resistance of 100 ohm, a capacitive reactance of 5 kilo ohm, and an inductive reactance of 300 ohm. When used at 2 megahertz, find the resonant frequency and bandwidth of the circuit. So again, the resonant frequency and then bandwidth, those values are given. And then third problem is, for the following circuit, find the resonant frequency. So this should be the answer. So today you all please, you make practice three problems. So go one by one. First, everybody see this circuit and find the transfer function V naught over Vi, and this is the answer. So unless you get the answer, so please everybody keep trying. Everybody, did you get me?
Yes, sir.
Yes. Yes. Please everybody take your pen, and this will be a great practice for you, because again there will be midterm exam to be held on September 21st. So that's why today you will make one practice, and sometimes next week I will make you another practice. So then you all will be ready. So please everybody take your pen, paper, and start. So I am giving you the hints, and then you just do that. You see that all four parameters were given, R1, R2, C1, C2 values are given. So how to get the V naught? See, if you can find out the current flowing through C2, then that current multiplied by the impedance, that is your actual V naught. So therefore, what you can do, first you find out the total impedance or equivalent impedance. Like R2 and C2 is in series, and then that combination is in parallel with C1, and that whole combination is in series with R1. And then that is your total G, and then find out total current, VI over that total G. And once you get the total current here, apply the current divider rule. Some current is flowing through C1 and remaining is going through R2 and C2. Your goal is to find out this current. And once you get that current and then multiply it by C2, that will be your V naught. And then you can find out this relationship, V naught over Vi. So then please you start. So as you can see, because you see answer, it is given in S, Laplace domain. So you express it in Laplace domain. So please you start. I told you that everybody try and see that you are getting this result and let me know. So therefore, like what I feel like you all need like lots of practice. Sometimes even though you understand problem fully or correctly, but still somewhere in the calculation you make some mistake, and that's why you ended up in getting the correct result here. That's why please you right now upfront to make practice. So I think you all remembered for Laplace S equal to j omega. For example, for capacitor C2, 1 over j omega C2, so S C2. J omega will be replaced by S, Laplace operator. So R is as it is. And then you put those values C1, C2, R1, R2. And then you do, then you should be getting this result. Then anybody, if you have any question, anything, then please feel free to ask me. I mean, don't hesitate to ask me questions.
Hey Doc,
Yes.
I sent you a message on the chat feature.
Oh, you did? Just a moment. I think, oh, then I think I have to stop sharing. Just a moment. What was the message? I have some one-on-one in few minutes with the, okay. Oh, okay. Oh, so you're fine. You're fine. Julian.
Okay, yes, I was hoping you knew about the curve repair.
Yeah. No, so you're fine. Yeah. So you can go. Yeah. Sorry, everybody. So again, I have taken you to that problem. Yeah. Is everybody trying this one?
Yes, sir.
Okay. Yeah. So as I told you, like once again, first you find out the total impedance. At the very beginning, you replace all j omega by s. For example, 1 over j omega c1. So this means 1 over s c1. Similarly, 1 over s c2. And then find out total impedance, find out total current, and then apply at this point current divider rule. Your main task is to find out current flowing through C2, and then that current multiplied by 1 over SC2, that will be your V naught. And then after some calculation, for sure you'll be getting this result. Just it's a matter of calculation. It's not difficult. And that I like you that you make that calculation practice. So like in your answer, in your transfer function, numerator, denominator initially might be different and then simplify. So finally see that you are getting this result after simplification. You see in the numerator only there is 5 and in the denominator s square 8s plus 5. So please bring this format. So have you all calculated the total impedance at first, and then have you been able to calculate the current I2? I mean, current flowing through C2, or still you are not there?
I'm not there yet.
Okay. So have you calculated the total impedance?
I got the transfer function.
Oh, this one exactly?
Yes.
So you are Brad, right? Yeah. Okay.
I
Okay.
believe that was phase-in, but I did find it too.
Okay. So exactly the numerator, denominator same.
Yes, sir.
Oh, okay. Great. Yeah, great. It's just a little bit long calculation, that's all. I mean, not difficult. So therefore, those who are done on this one, you please, so look this one. So you please start this problem too. So what I would recommend you, can you please just take a picture of this slide? So that again, I will go back to that previous problem for everybody. So those who are done with the first problem, please you take a picture of this problem and then answer are written. And please you try and then see that you are getting this result. And then again, I will come back to this slide. Did you take a picture of this slide?
Yes, sir. I'm good.
Okay. So then I am coming again this slide. Okay.
For one, I also got the same result.
Oh, you got the same result? Yeah. Okay. Oh, great.
Mm.
Great. Yeah. Okay. So everybody, those who are still trying, that see, I was calculating. See my calculation. Look the left side. This is the total impedance. Left side. You see what I did? First, I converted those to C1 and C2 into S form, 1 over j omega C1, 1 over j omega C2. So first one became 10 over S after putting its value 0.1 farad, 0.2 and 5 over S. And then see what I am doing, that R2 plus 5 over S, that is in parallel 10 over S. Then this combination is series with R1. So therefore see, my total J I have expressed in that format. 2s squared plus 16s plus 10 over s into s plus 3. In that format, I have put. So you might put in different format, but like after simplification, I put in that format. And after that, you see right side, first I am finding total current, VI over this total impedance, and then I am finding IC2. This is the current divider rule. And then I got in that format. And then I am calculating V naught S. IC2, I mean this current multiplied by that C2 impedance 5 over S. And then I got this relationship. So finally, this is my result. So everybody, those who are still trying, so please see this one and then you match and you see that where you are stuck and where did you make mistake so that you can check. So the goal is that you have to solve it correctly, and that is the main goal, that practice you are making. So as I said, that even though you understand so well sometimes, but when you really do in pen and paper, then like you got stuck somewhere or you get incorrect result. That thing you have to do, like just algebra practice or simple math practice. So everybody, could you follow me? Are you looking my screen? Yes.
Yes.
Yeah, so please see, and then where you made mistake, and you see the left side, you see left side, this is the total impedance. So see, this is the total impedance, and then see the process, first IT, and then IC2. And even though you might do using the loop equation, for example, current loop equation, you could do. So whatever way you do, still you should be getting the same result. So you might apply other technique, may not necessarily exactly this thing, but still you should be getting the same result. Therefore, you see your calculation, that how you are doing, what you are doing, and then where, so where is the discrepancy between my calculation and your calculation, then you will be getting it, what mistake you are making. Is everybody fine? Should I jump to the next problem, or still you are calculating?
I think we can move on to the next one.
Okay, so everybody, and then again, you know that after the class, definitely I will be uploading this one. Still, I did not upload this practice thing on the eCourse site. Definitely, I will be uploading these slides. Plus, of course, you will see the video. Right. So therefore, the goal is that everybody see that sometimes in between somewhere you made mistakes, like even though you understand the whole process, but like when you are calculating. So that is the thing that I am doing today. Like you are making practice. So everybody see and then try to get that result. With that, now I am moving the next problem. Okay, everybody please read this one. In an electronic device, a series circuit is employed that has a resistance of 100 ohm, a capacitive reactance of 5 kilo ohm, and inductive reactance of 300 ohm when used at 2 megahertz. So this is the frequency, megahertz. So based on that, find the resonant frequency and bandwidth of the circuit. So again, the answers are given. So you see, in the class, few classes back, we discussed both series resonance and parallel resonance. We had series circuit, parallel circuit. So this is with regard to that series circuit. There is all three components: resistance, capacitance, inductance, and then find out the resonant frequency and bandwidth. So therefore, for bandwidth, you have to use the equation for series circuit. So for the parallel circuit, it is different. And just keep in mind that for capacitance, that 5 kilo ohm is it is reactance. Similarly, for inductance, it is not Henry, it is its inductive reactance. And that's why the frequency is given. That frequency is 2 megahertz. So then find the resonant frequency and bandwidth. Okay, so those who are trying from before number 2, is anybody is done with number 2? Did you get the result that I got? Anybody?
I think I'm on my last step.
Oh, okay, okay. So the resonant frequency 8.165 approximately megahertz, and bandwidth 4.19 approximately mega radian per second. Mega radian per second. So in both cases. same.
Yes, sir. I think I got it now.
Okay, so both results are correct.
Yes, sir.
Okay, great. So everybody see your note, or you open the previous class lecture. This is for the series resonance. See the resonant frequency and bandwidth. Look the bandwidth equation for that series circuit, and then circuit parameters are given, but resistance is fine. You have to take care about capacitive reactance and inductive reactance, because those are given in terms of ohm. And then frequency f, this is the value of f, 2 megahertz. Keep in mind, this is not the omega, this is f frequency, because omega will be expressed in terms of radian per second. Frequency, normal frequency, always expressed in terms of hertz. In this case, it is megahertz. So here is the hints. So therefore, as a full hints, see that how you can relate the frequency with that capacitive reactance 5 kilo ohm. How it is related. That and similarly, how the frequency is related to the inductive reactance of 300 ohm. So inductive reactance value is given. So then by using frequency and 300 ohm, can you find out what is the value of L? Similarly, capacitive reactance 5. So by using 5 kilo ohm and 2 megahertz, can you find out the capacitance C value? That's the thing. So you have to find out what is the C value and what is the L value by using this information. Then you are done. Then you can find out the resonant frequency. So you see, I have expressed the result in hertz. So you don't need to find out the omega naught. I mean, you find out omega naught, but then once you get omega naught, you see omega naught is 2 pi f naught. So you can divide that result by 2 pi. So that will be your megahertz. So therefore, those who are done number 2, so please you say number 3. This is the last problem for today, number 3. So therefore, again, I would recommend you all who are done on 2, for 3, please you just take a picture, and then I will come back this slide later. Please take a picture for this slide. For the following circuit, find the resonant frequency. And then I have written down the answer, 4.841 kiloradian per second. So please take a picture on your phone for this slide, and then you keep trying, and then I'm coming again in this slide. Have you taken a picture of this one?
Yes, sir.
Okay, and then please keep trying and see the answer, and then I'm coming back. So everybody, first, did you calculate the value of capacitor and inductor from this information?
I didn't hear. What did you just ask right now?
I said that what is the value of C, capacitor, and then inductance L?
Oh.
First, you need to, you see the resonant frequency, everybody know that omega naught is 1 over root over LC, right? Yeah, that you know. 1 over root over LC. So now you might not directly find out the value of C and then L, but because inside the equation 1 over root over LC, you need the value of L and C. So that thing I am telling, see, look the statement. resistance value 100 ohm, that is fine, that is R value. But capacitance value is not given in terms of farad or microfarad. It is given in terms of reactance. So therefore, everybody listen to me. Capacitive reactance means this is XC. XC. So what is XC? X is 1 over omega C, 1 over 2 pi FC, right? That is. So then that frequency is given. That F value is 2 megahertz. And that XC value is 5 kilo ohm. From there, you will be getting C. So X is 1 over 2 pi FC. Similarly, for inductive reactance, XL equal to 2 pi FL, 2 pi FL. Then again use the frequency F value 2 megahertz. From there you will be getting L value. And then once you get C and L value, then you are able to calculate the resonant frequency. And then also you can calculate bandwidth. Everybody see, bandwidth is R over L. R over L. In the numerator R, denominator L value. That's why you must need the L value. Everybody, could you follow me what I said?
Yes.
So like typically you have noticed in other problems, C value and L value are directly given. But in this case, those values are not directly given. Those are expressed in terms of reactance. Capacitive reactance, inductive, XL and XC in that format. So that is the very first step, that from there, using the frequency formation 2 megahertz, first you have to get the value of C and L. Then you are able to do. And then it's just a matter of calculation and usage of your calculator. That's all. Then you should be getting this result.
So I got the resonant frequency fine. So that makes me think my L and C values are correct, but I didn't get the bandwidth when I did the division. I did 100 divided by L, and I did not get that.
Okay.
Not sure.
So just a moment. You see, my calculation bandwidth R over L. R is 100, and L just I
Oh.
put.
I didn't divide by 2 pi.
Okay.
So when I multiplied the two terms, both of them didn't have the 2 pi, so my resonant frequency turned out fine, but my
Okay.
my L value is wrong still.
Okay. So therefore, everybody keep in mind 2 megahertz is not the omega. That is F. That is the thing. Very first thing I told you. Everybody see. The frequency, it is not omega. It is in terms of F. That's why unit is hertz. When it is omega, always it will be radian per second. That's why you see the answer I have expressed in terms of hertz, megahertz. So therefore, those who are trying, so therefore see, first I wrote down, everybody see, first I have written down resonant frequency equation, F naught 1 over 2 pi FC, root over LC. Why I did that? I mean, because I want to express in frequency, hertz, that's why. I mean, of course, you might find out omega naught at first, and then later you might divide by 2 pi. So then you will be getting answer in megahertz. So therefore, you see on the left side, see what I was telling, XL is 2 pi FL. Therefore, from XL equal to 2 pi FL, you see at the bottom, I am finding L. L is XL over 2 pi F. And then see X is 1 over 2 pi FC. So from there, you see, I am finding C 1 over XC 2 pi F. And then you see inside root over LC, I am putting the L value by using this equation and the C value by using 1 over this one. And then it's just a matter of calculator. You should be getting about 8.165 megahertz. And then bandwidth be R over L. Again, R was given 100 in the problem, and L value, I just expressed this one, XL value was 300 over 2 pi F. So you see, I did not directly calculate L value and C value. I just express in that format in the equation, 300 over 2 pi f, 1 over xc 2 pi f, 1 over that one. In that format I have put. So you might calculate and then put, still you should be getting the very similar result. So you see the bandwidth B I have expressed in 4.188 multiplied by 10 to the power 6 radian per second. That's why you can write 4.19 mega radian per second. Everybody, could you follow this calculation? See the left side, these are the main thing. XL and XC. From there you will be getting L and then you will be getting C. Because unless you get L and C, you cannot plug in that equation. Either this equation or omega naught equation, you need that root over LC. You need to get the value of LC. And then the rest of the thing is your calculator. Use your calculator and get this result. So as long as you are writing this thing correctly, then you should be getting this result. And once you get, then see the bandwidth. Everybody, do you understand the process?
Yes.
Yes. So main thing, first look the procedure, that how to do that, what things are given, and then how to get the parameters. And why I am writing XL, XC, because those values are given. XL is 300 and XC is, I think XC was how much? XC was 5 kilo ohm. You see this on XC and this on XL. Those values are given. So now utilizing those things, get the value of L and C, and then plug in the equation. So therefore, it's not difficult. Just the matter of calculation and getting the correct result. That's the thing. Therefore, so everybody, once again, because I will be uploading this slide, so you can see. So I hope you are trying, and then you keep going, see that you are getting exact results. So is everybody fine? I want to move the next problem.
Yes.
Okay, so I am moving the last problem for today. Everybody see this one. For the following circuit, find the resonant frequency. Again, I think we discussed two problems in the class, and then I think you are assigned on problem in the homework, right? Yeah. And then again today, another problem. So this means including this on similar 4 problems I am discussing, because these questions are frequently asked in the FE exam. So that is the reason, like I am giving emphasis this type of a specific problem, calculating the resonant frequency. Pretty standard questions often asked in the FE exam. So those who started trying this on before, did you get this result so far, or still trying?
I think I'm doing it correctly. I'm doing it by finding the admittance, but I'm just getting lost in algebra again.
Okay. So you see that you should be getting 4.841 approximately kiloradian per second. So therefore, everybody, what is the hints here? You see, this is the parallel circuit, right? This is current source, and then this is one branch, and this is other branch. So you express the Y. You calculate the admittance for this circuit. And once you calculate the admittance, then at the last, you express real and reactive. In that format, you represent the Y admittance. And then because you are finding resonant frequency. So the imaginary part should be 0. And then you write imaginary part 0. From there, you calculate. And so you should be getting this result. So find out the admittance Y for this circuit, total admittance. So therefore, what is the main thing? What thing I am emphasizing each of you that like even though you understand the problem, you know how to do, but then when you start, the calculation is also important. Correct calculation, correct algebra or correct math, correct phasor algebra, that is also important to get the correct result. Therefore, if you are understanding well, but then in calculation you are making lots of mistake, then never ever you will be getting the correct result. Always like you will be getting the wrong result. That's why both things are important. I mean, correctly understanding and then correctly solving. That's why everybody, please be very careful and very serious about the calculation, correct calculation. It's just algebra or simple arithmetic. Even, I mean, no calculus or no trigonometry, nothing.
Dr. Ali,
Yes.
I feel like I'm overcomplicating this, but the two in the middle branch, the resistor and the inductor, since we're calculating admittance, we can't just combine them normally, can we? So it would be,
Yeah, no, yeah, but first you do like their impedance.
yeah, so
And
first
then
do their impedance and then
on
change it.
over G, right.
Ah, okay, thank you.
So therefore, for example, 50 plus j omega L, and then on over G. That is your impedance for middle branch, and then right side on over j omega C. On over j omega C, then ultimately j omega C. Or in other words, you find out y1 and then y2, and then sum up.
Pretty sure I finally got it now.
Yeah. So therefore, see my everybody see my very first line y. For the last branch, on over j omega C, like on over xc. So first I am doing for this one on microfarad. So impedance is on over j omega C. That's why admittance on over j omega C plus second portion this plus this 50 plus j omega L, that is impedance, then on over. So you see on over, that is the y, and then all the way I am dividing real and imaginary. So finally I got that one. Yeah. So so you got the correct result, Brad, right? Yeah.
Yes, sir.
Oh, okay, great. Yeah. You see, it's just the matter of calculation, and also like your calculator should help you. Your calculator should give you the correct result. Otherwise, you will end up with wrong result. So therefore, even when pressing the button in calculator, be careful. Otherwise, you will get completely different result. That's the thing. I think in the homework on a little bit, I think very similar, but a bit, I think, complicated than this one in the homework on. So therefore, like for everybody, while they are trying, they see, like I was calculating here, everybody see, I am finding y. I already explained the first line, and then you see, like how I am going. And then here, this portion is my real part, and then right side, this portion is my imaginary side. Therefore, you see, I have written for resonance, imaginary part of y is 0. This means this portion is my 0. And then just see in 2 and 3 lines, I am getting omega 4.841 kiloradian per second. So therefore you see your calculation and then you match that where is the discrepancy and then how you are going like up to now, even you see, I did not calculate. I just kept in that format, like 50 squared, 0.04 squared, omega squared. I have left in that format. So like at the end, I am calculating. I'm keeping all in that format. I mean, you can get the actual number. That will also work. But like I put in that way, and then at the end I got this one. This one 0.04. I think I wrote 0.4. That's why, like I marked by pen j omega 0.04. That this number j omega 40 multiplied by 10 to the power minus 3. Is everybody looking and doing this calculation?
Yes.
Yes. So please, everybody see that like what you are doing and where is the mistakes. So just here 1 over 50 plus j omega 0.04. Here I am, because in the denominator, I want to get rid of the j. That's why I am multiplying by the complex conjugate of 50 plus j omega 0.04. This is minus, so in the numerator minus, and then just simple calculation. And then separating out real part and then imaginary part. That's the procedure. So therefore, in the homework, you have been assigned on problem. So everybody, you must understand this process, and then exactly you have to solve that homework problem as well. And then, of course, again, definitely you can expect on similar problem in the upcoming midterm exam 1. Okay, so everybody, so you please keep trying, and I'm going to upload these slides. I mean, right after the class. Then you can see and you can match with your calculation. But I believe we have started, so you see and how you can get that result. I think some of you have next class, so I am going to stop here. So is everybody fine? So does anybody have any questions or anything? Do you have any questions on this slide, on this calculation?
Seems pretty solid to me.
Okay, yeah. So therefore, everybody, please keep going. I am stop sharing here.